12 grams of oxygen. We'll measure in grams. Normally we do it, I don't want to do this, it's 22.4 liters per mole. So it'd be in liters. We'll just do it in grams to keep it simpler for our calculation here. All right, so we have 12 grams of oxygen, and I'm going to get CO2. So how much carbon do I need to bring into that oxygen to get carbon dioxide? This, by the way, is not a real chemical reaction. I'm trying to keep the thing really super simple, okay? So, yes?
6 grams.
6 grams. Now you might think that because I have twice as much of that, but their masses are different. Okay? So if I have 12 grams of oxygen, I'd have to do it like this. I would need to know how much does the oxygen weigh? What's oxygen? (16). So oxygen is 16 grams per mole, right? But this is O2, so it's 32 grams per mole. Okay? 32 grams per mole.
Oh, that makes
Okay, very good on that so far? Okay, I'm not trying to create confusion, although I know I'm good at it. So let's just go back and make this even simpler then, okay? So instead of having 12 grams, we have 32 grams. Okay? That way I don't want to get bogged down in the math, I just want you to see the relationship here, okay? So if I have 32 grams of oxygen, that's how much that weighs. So now, how much carbon would I need? So this, let me just show you, without even knowing carbon, okay? So if I have 32 grams of O2, the ratio here is 1 to 1, right? 1 mole of that for 1 mole of that. Okay? No, because this is 32, so a mole of O2. O2 is a diatomic, well, it's a diatomic molecule. It can't occur by itself. Well, right now, who can tell me how much carbon I'm going to need? Max?
16.
What?
16.
Nope. Chloe?
Explain the ratio between.
Yeah, so this is 32 grams per mole. So I'm telling you I have 32 grams of it, right? So that means I have 1 mole. And by the way, this is another one that cracks me up. So do you know what the abbreviation for mole is? M-O-L instead of M-O-L-E. Like, not the world's greatest abbreviation. Too many things already have M, I guess. So 1 mole of O2. So here, the ratio, I can see that what I get is for every 1 of these, I get 1 of these, right? Everybody see that? Okay. So then the question becomes, how much of that do I need?
42 or 43.
How'd you get that?
Because so before you had 12 grams of oxygen, and then you had 32 grams.
No, forget about the 12 grams of oxygen. I made it 32 grams just to keep the math
I'm like
simple.
using dimensional analysis. The weight of oxygen is 12. No, is 32 the carbon or the oxygen?
The oxygen.
Okay, and so oxygen weighs 16.
And this is O2, so it weighs 32.
Okay, then never mind. It's not right.
Sophia?
12 grams?
12. Yeah.
Are you kidding me?
It's 12 grams.
How?
You just had to leave this little wild goose chase. You could have just have said.
I wanted you to try to reason it out. So if 1 mole of this weighs 32 grams per mole, so it's 1 mole, so the ratio here is 1 to 1, so 1 mole of carbon, how much does 1 mole of carbon weigh? 12. Okay, 12.011 if you want to use the average numbers. Okay,